Hey everyone, welcome back to another exciting journey through the cosmos. Ever wondered what's really inside a neutron star? These stellar remnants are some of the most fascinating objects in the universe. Let's dive into this cosmic enigma and unravel its secrets together. Buckle up, because this is going to be a wild ride. First off, imagine this. A massive star collapses in on itself after a supernova explosion. Gravity goes haywire, pulling everything inward with such force that it crushes the core into an incredibly dense object. And voila, a neutron star is born. Just a teaspoon of this star weighs as much as a mountain on Earth. Imagine holding that in your hand. Yeah, let that sink in. The density is mind-boggling. Inside, things get wild. The environment is so extreme that normal atomic structures can't exist. Electrons and protons merge into neutrons, and guess what? This process leaves no empty space. No empty space is left. The particles are packed so tightly that the star becomes a solid mass of neutrons. What you have now is a dense, fluid-like mass of neutrons. It's almost like a giant atomic nucleus. Think of it as a neutron soup, where neutrons move freely in a dense, fluid state. Encasing this soup is a thin, rigid shell that's stronger than steel. This outer crust is incredibly tough. But even this tough outer crust isn't immune to starquakes. These are like earthquakes, but on a cosmic scale. Just beneath, in the inner crust, you'll find crushed nuclei and free neutrons mingling in a dense, exotic mix. It's a chaotic environment. And then, things get even weirder with nuclear pasta, matter that bends and twists into spaghetti-like shapes. This is due to the immense pressure and density. Moving deeper, neutrons in the outer core move freely, forming a superfluid that's, wait for it, frictionless and totally bizarre. Imagine a liquid that flows without any resistance. At the heart, extreme pressure forces matter into unknown states. The conditions are so extreme that we can only theorize about what happens here. Scientists are still scratching their heads over what exactly is going on here. It's one of the biggest mysteries in astrophysics. Some think neutrons might break down into quarks, forming a quark soup. This would be a state of matter we've never seen before. Or maybe even more exotic particles like hyperons might exist under these extreme conditions. The possibilities are endless. And don't forget the star's magnetic field. It's 1 trillion times stronger than Earth's. This magnetic field can have dramatic effects on the star and its surroundings. Some of these stars spin hundreds of times per second, faster than a blender on turbo. This rapid rotation can create powerful beams of radiation. These spinning stars can beam radiation, acting like cosmic lighthouses known as pulsars. They are some of the most precise clocks in the universe. Their gravity, 2 billion times stronger than Earth's. It's a gravitational monster. This intense gravity can warp space-time around the star. This gravity is so intense it actually slows down time around the star. Time dilation is a real phenomenon near these objects. When two neutron stars collide, they create gold, platinum, and even ripples in space-time. These collisions are cosmic events that can be detected across the universe. If the core is heavy enough, it might even collapse into a mini black hole. This is the ultimate fate for some neutron stars. The truth is, scientists are still debating what's really inside, nuclear matter, or something even stranger. The debate continues as we learn more. A neutron star is a cosmic paradox, dead yet filled with mysteries. It's a stellar remnant that challenges our understanding of physics. And that's a wrap on what's really inside a neutron star. We've only scratched the surface of these incredible objects. Keep looking up and keep wondering. The universe is full of wonders waiting to be discovered. See you next time.